Welcome to another lecture on industrial engineering. So in this video we are going to discuss about Johnson's rules for three machines. We have seen Johnson's rule for two machines and we have discussed about the algorithm for the sequencing of jobs on two machines. Here also we assume that all the jobs have the same sequence. All the jobs have the same sequence, but there are three machines. So let us understand this rule, explore this rule with the help of an example. So the example given is the job. There are five jobs, 1, 2, 3, 4, and 5, and there are three machines, machine 1, machine 2, machine 3. Okay, the job 1 goes through machine 1. It is first processed in machine 1, then in machine 2, and then in machine 3. So our problem is to sequence this job. That means we need to determine which job should be sequenced first, and then after that which job should be sequenced, whether it is job 2, after that maybe 1, 3, 5, or like that. So we need to find this sequence. So we are using the Johnson's algorithm. Okay. So earlier we have seen the Johnson's rule for two machines. For three machines, we will uh, use a simplification. The simplification is that if look at machine 1, the time taken in machine 1 for these jobs, you can see that the minimum time taken is 6 for machine 1. This is the T minimum. And for machine 2, the T maximum is 6. Okay, we are not considering machine 1. So we are making a simplification. So this can be applied only if the minimum of the time taken in for the jobs in any machine is greater than or equal to the maximum of the time taken in another machine. So this condition is valid because here the T minimum is 6 for machine 1 and the T maximum is 6. You can see that 6 is equal to 6. Okay, so this condition is valid. So if this condition is valid, then we can sum these times and convert that into a single machine. So in this case, 8 plus 5 is 13 and 10 plus 6 is 16, 6 plus 2 is 8, 7 plus 3 is 10, 11 plus 4 is 15. Okay, so we are reducing the three machine into two machine, that is machine G and machine H. So here the time, so machine so the machine H is the sum of these two, that is 5 and 4, that is 9, then 6 plus 9 15, 2 plus 8 10, 3 plus 6 9, and 4 plus 5 9. So the three machine is reduced to a two machine problem, and then you can apply the Johnson's algorithm for two machines. So let us see how we are going to sequence the jobs. So according to Johnson's rule for two machines, the smallest processing time for machine G is, so smallest, we look at the smallest time. So smallest time is 8, that is for the first machine G. So we will sequence that job, that is job 3, corresponding to 8, it is job 3. Then the next smallest processing time is 9. Okay, so you have a so all job 1, 4 and 5 all have the same processing time. So the smallest processing time is 9 hour for job 145 on machine H, and for this job 10 is smallest on machine G. Okay, so you can look the corresponding values in machine G. You can see that the smallest one is 10. Okay, so we will select 4. Next smallest processing time is again 9, and we will select job 1 because corresponding to 9, 13 is the smallest. Here you have 15. So the 1 is selected. Since it is in the second machine, we are scheduling to the last. So next smallest processing time is again here 9. So we will schedule 5 here. Okay. Then, so there is only one job left. So that is 2. So the sequencing will be 3, 2, 5, 1 and 4. So according to Johnson's algorithm, the optimal sequence is as below, that is 3, 2, 5, 1 and 4. So this is the sequence. Now we will find out the make span time. So we know the sequence, that is 3, 2, 5, 1 and 4. So for the machine 1, all these jobs have the same sequence, that is first goes through machine 1, then 2 and then 3. So it will enter at the 0th time. So the processing time is 6. So after 6 it will enter machine 2 and it will take plus 2, that is 8. Then 8 plus 8, 16. Okay, so now the idle time for machine 2 is 6 because the machine 2 needs to wait for 6 minutes for the machine for the job in machine 1 to be finished. So it is waiting time is 6, and idle time for machine 3 will be 8 because it needs to wait for 8 minutes before the job need to be started. So then after machine 1 is free after 6 minutes, so you can start job 2. It will start at the 6th minute, also 6th unit of times. So it is 6 plus 10, it is 16, and it will enter, go to machine 2 at 16, and then 16 plus 6, it is 22. And for machine 3, it will enter at 22, and here 22 plus 9, it is 31. Okay, now look at the idle time for machine 2. So machine 2, the job 1 is over at the 8th minute. Now the next job will come only at 16 minutes. So the idle time is 8. Similarly, for machine 3, the job is finished at the 16th minute, but the job 2 will arrive only at at 22. So you need to wait 6 minutes. Okay, similarly for job 5, you can find out similarly in the similar fashion. And in with job 1 also you can find out the times, and job 4 also you can find out the times, and the total time is 51. So 51 is the max total minimum time elapsed is 51. So so it will take 51 units of time, let it be minutes for time's sake. It will take 51 minutes to complete the all the jobs. And idle time for machine 1 will be 51 minus 42. Okay, because job is completed at 42nd minute, but the complete operation is completed at 51 only. So 51 minus 42, it is 9. And for machine 2, the idle time we have calculated it to be 31. Similarly, you can calculate the idle time for machine 3. So this is how you apply Johnson's rule for 3 machines. So idle time for machine 3 can also be calculated. It is 90.